Okay, welcome to the last meeting, which is not a lecture. I'm not going to talk about anything new in this lecture, which is not a lecture, but I'm going to talk about some things that are nevertheless very important. I want to talk about the final exam. I think many of you, and looking at the mock exam, many of you don't know how to write an exam. So sometimes you may know the answer to the question, sometimes you may know part of the answer to the question, but because you don't know how to write it, you put yourself at a disadvantage because you don't exhibit your knowledge to the examiner. And you have to realize that it is your duty to convince the examiner, the person who's marking your exam, that you know your stuff. It is not the duty of the examiner to build up a case that indeed you know your stuff. So bear that in mind, that you have a responsibility. And something that's very important, unfortunately, because if we were computers or machines or robots, maybe that would not be the case, but it's very important to get the benefit of the doubt. Sometimes there's doubt in the mind of the examiner whether you know or you don't know, and if you present your exam paper in such a way that you get the benefit of the doubt, then you will get more points and more marks, and sometimes they can be the difference between passing and failing. Something that's very simple and yet people don't do it is to write legibly. It is important that your examiner understands what you are writing. Okay? Try to write legibly. Have your answer organized. Organized means when you write something, go left to right, top to bottom. So think a bit before you start writing, so you don't start writing and then you remember things and then you start putting arrows and then sending to different pages and having your presentation very random and disorganized, because it just doesn't look good. It makes it tedious for the marker to mark it, and it's going to cost you. When you want to change something, just if you made a mistake, just cross it out with a line so that it's clearly crossed out, and just write underneath. Don't scribble over, don't try to insert things, don't try to make references, just cross it out neatly and write again. It's just as simple as that. Make it neat. And also, please, we are not fools. Do not write nonsense. This is not, in the humanities or whatever, if you're asked to write an essay, maybe you can write something that's vague and vaporous and impressive sounding and have kind of a soup of big words that they look, maybe you know what you're talking about. This really doesn't work here at all. It's just tedious, and it looks like you're trying to camouflage your lack of knowledge. So do not write nonsense. It doesn't help. It's not gonna. Sometimes it might even hurt you. So I put all these under the category have respect for the marker. So the marker is a person, me. I might get some help from some of the demonstrators, but I tend to do most of the exam marking myself, because I find that sometimes the young ones are quite harsh with their marking, and I don't like that. So I do the marking as much as possible myself. So respect me. Don't try to fool me, and then don't try to don't give me extra work, unnecessary work to decipher difficult to understand answers. There is going to be, obviously, some OCaml code writing, some proof writing, and maybe a need to write some text. And let me tell you how you do that. When you write OCaml code, in addition to everything else that I said, which is writing neatly, legibly, and being organized, in addition to that, You don't have to be overly concerned with the concrete syntax. For example, brackets, or whether you write let rec or let, or I'm not going to run a spell checker and look over tiny mistakes. I don't care if you make tiny mistakes. So don't be overly concerned with that. Should I put 2 semicolons at the end or not? You may or you may not. It doesn't really matter. This is something that's something people sometimes call morally correct code. So I'm just gonna assume that the syntax is okay. The code for functional programming, unlike something like Java, it's usually self-explanatory. And if you write a clear solution, it should be self-explanatory, and you shouldn't have a lot of comments and explanations. But if you think there is something non-trivial in there, and if you want a concise, snappy explanation, that's fine. But make it concise. Don't write an essay explaining me your code, because it's just, I prefer the code to be self-explanatory. Put that effort into making the code self-explanatory. Also, always, several small functions that are obvious are preferable to one big complicated function. It's easier to read for me, it's easier to get right for you. Unless the question explicitly asks it, for example, you have a question that says, write a tail recursive implementation of this or that. So unless the question itself asks it, do not be concerned with correctness within the bounds of common sense, right? So don't write things like, I'm going to write a sorted list. I'm going to calculate all the permutation, and I'm going to select the one that's correct. Yeah. So not something that as silly as this. So don't be focused on efficiency, but be focused on correctness within the bounds of common sense. And also, if you have time, sanity check your code by running it by hand on a small example. If you have time, it's very useful, and it will help you find lots of errors. So if you write some program that works on list, if you try it by hand on an empty list, if you try it by hand on a list with 1 or 2 elements, it should usually gives you a good indication whether your program was correct or not. Writing proofs, there will be structured induction, that's for sure. We spend a lot of time on structured induction. And for structured induction, the important thing is to indicate clearly that you know what you're doing. So just say explicitly on what variable or variables you do the induction. Indicate clearly what the cases are that you are taking. The head, the tail, the empty list, and so on. Or if there's a tree, what the cases are. So it's very important. And also indicate clearly where you are using the inductive hypothesis. Because if it's a proof by induction, really, the induction hypothesis is the magical ingredient that makes it work. So these 4 things, what you induct on, what are the cases, and what the induction hypothesis is, 3 things, are very important. So make sure that they are very, very clearly identifiable. If you have a proof where you have to prove something that's equal, if possible, I would prefer that you start with the left-hand side and you start going left to right until you get to the right-hand side. So many people write something like that. We want to show that the bottom there is not quite visible. I don't know why. So let me just do it like. Maybe fine. Okay, so some people tend to write things like this. Let me write it here because it's cut off for some reason. I don't understand why. So they go, I want to prove that left-hand side is equal to right-hand side. and then they do things to the left-hand side, and they do things to the right-hand side, and they write something is equal to something, and then they keep working on the left-hand side and the right-hand side, and they get to true, something like true equals true. And they say this is a proof. And this is not really, logically, this is not a proof, because if all you use here is implications, what you have proved is that something implies true. Well, from logic, you should know that everything implies true. What you want is really these arrows to go in the other direction. So true implies what you're doing. But this is kind of a difficult way to read a proof. I'd rather, if at all possible, to just go left to right. So you start with the left-hand side and you end with the right-hand side, if possible. This is not a big deal. You may be asked to write text. I haven't done it before in an exam. It's not likely, but it's on the card. So you have to explain something in your own words. And there, again, the important thing is concision, being to the point. Bullet points are okay. And the important thing is that you know and you are able to select what are the relevant concepts and use only those relevant concepts. So when I'm marking, I'm looking for the keywords. Because if you're able to select the relevant concepts, then that means you understand. You don't have to, there's no marks for beauty of prose here. How is the exam marked? So you have to realize that there's going to be almost 200 exams and maybe 1,000 questions to mark. So I'm not going to have the resources to pore over every question and really try to make a very deep analysis of what you're doing. So try to give answers that are obviously correct. So that's why I'm asking to be neat and clear and well organized in the presentation. Because when I'm marking, I'm looking from the beginning, I'm looking for some things. Is the answer sensible? You can spot immediately if something is sensible or something is nonsense. If it's nonsense, then usually I don't need to go any further. Is the structure okay? If you're using recursion or induction, I just want to see that you know how to use the main structure, the cases and the recursive call or the induction hypothesis. So that's kind of a pattern match on what you do. If that's okay, probably you're already on your way of doing well. Are the basic concepts understood and used correctly, or are there glaring errors? What I don't do, I'm not going to look with a magnifying glass to find tiny little errors, so I'm not going to nitpick your answer, trust me. That's not the point. The point is for me to see that you exhibit understanding through your answers. I don't really care if your answer is perfect or not. But also the upshot is that I cannot understand overly complicated answers. If a question has a simple answer, you are expected to give the simple answer. If you give me a super complicated answer, maybe it's true, maybe it happens to be the correct answer, but if it makes it impossible for me to assess whether it's correct or not, then up front I'm telling you this is not going to be good enough, because it's very difficult to, like if you write the program, it's very difficult to write an obfuscated program, which you know it's correct, but nobody else can tell what's going on with your program. So bear in mind that the point of the exam is for me to have you demonstrate understanding to me. And part of the understanding is coming with the simplest and an intelligible solution to the problem. And here is how not to fail. It's very easy not to fail this exam if you pay attention. The first thing is attempt all questions. Don't write nonsense, but write what you know. It can be a very difficult question, a very difficult proof. Maybe all you can do is say, I'm going to do induction on this variable. This is the pattern of induction, and I'm going to elaborate a little bit the base case. The base case usually should be easy to do. And then I'm going to elaborate a little bit the inductive case. And that should give you enough points, maybe not half the points for that particular problem, but those points can be overall the difference between passing and failing. So attempt all questions, but without writing nonsense. The little that you can do, the little that you know, write it down neatly and clearly. The important thing is to identify and focus on answering the easy questions very well. Don't just go over the easy questions, because if you get the easy questions wrong and then you don't know how to do the hard questions, then that's usually, unfortunately, a way in which many people end up failing. So if you're concerned if you don't think, this is primarily aimed at those who are concerned with passing. So if you're concerned with passing, you want to make sure that you don't fail, really focus very well on the simple problems and do them well. In general, for the questions, if there's a question that you don't know how to do, if there's a question that you don't know how to do, give a partial answer, but acknowledge that the answer is partial. So don't give a partial answer as if it was a complete answer. There's a big difference. The difference is between somebody who knows what they're doing and somebody who doesn't know what they're doing. If you do something that's partial and you say, this is just as much as I could do, then you get more points than giving a partial answer and saying, I think this is a complete answer. So how can you give a partial answer? For example, you can leave helper functions unimplemented. So you can write a function in OCaml, and in that function you can use other functions that you don't know how to implement. And you just describe those functions in words. I say, okay, this is the function that I used, but I'm using this other function that I should implement, but I don't have time or I don't know how to do it. And then you can explain a little bit in words what those unimplemented functions would do. And then you can get lots of points if you do that. Another way is to solve a simpler version of the question that's asked. Again, acknowledge. So it's not a misunderstanding. Say, I cannot solve the problem as stated, it's too hard for me, but I am going to make an extra assumption and I'm going to solve the problem or implement my program subject to an extra assumption. That's fine. You're going to get some points deducted, but if that's the best you can do, then that's the best you can do. It's better than leaving it blank. In a proof, you can leave some steps unjustified, but explicitly unjustified. Say, I would like to get from here to there, I don't know how, but I'm stuck, so I'm just going to carry on nevertheless. So do that. But acknowledge the fact that you skipped a step that you don't know how to do. The important thing is not to get stuck. Because if you have time, you can always come back and fill those gaps. If you left some things unjustified, you can always come back and try to justify it or try to implement it. And finally, you cannot see there as a final resort, work out an example if you cannot do the proof. Do something. But say, this is don't pretend it's a proof. If you work out an example and you pretend it's a proof, you get 0 points because you don't know what you're doing. If you work out an example and you say, I don't know how to prove it, so I'm just going to show an example where it works, then you get some points. So it's a very important distinction between doing something randomly and doing something that exhibits some degree of understanding. So, for example, I'm just going to give you an example now of possible question in the exam. So let's say that it says define a function rev that reverses the order of the elements of a list. Define a function mem that tests whether an element is a member of a list. And then that prove that for all the lists xs and all elements x, membership in xs is the same as membership in the reversed list. And note, you are not allowed to use any library calls. So you have to implement everything that you are using. So of course, the solution would look something like this. And I highlighted certain things in different colors. So in green are things that maybe you would get wrong. So for example, maybe you forget to put rect, or maybe you forget to put the bracket, or maybe you forget to put 2 semicolons at the end. Those are the kind of things for which you would never get deducted any points. It's just small syntactical things that don't really matter that much in terms of exhibiting understanding. In red are the things that are essential for you to exhibit. For example, the recursion pattern. You can see the empty list and the head tail. It's very important to exhibit those. In the append function, using the constructor versus using the append, that's very important. If you get them confused, that's a big mistake because you are confusing two things that are quite different in nature. Using the append with a list that contains one element rather than with an element. That is conceptually important because you cannot append an element, you must append a list. Okay? So these are some examples that how would you write the things that could go wrong and are important, and you should try not to have them go wrong, and things that are not that important. So this is what I just said. And then there are other possible minor problems. For example, you can forget that at is not a language operator but a function call, and you might forget to implement it. That's not a big deal. The penalty would not be very big for that. Or going for the tail recursive reverse instead of the naive reverse, because you might think, that's more efficient. Well, it's not going to be more efficient for you in the exam because it's going to make it more difficult to reason about it. So that's why it's important to go with a simpler one. And now here is an example of writing a proof that there are parts of it that you don't know, but is the kind of an incomplete proof that you would get 75% of the mark for that question for. In red are the essential cases. The fact that we use induction on excess, and then what the cases are, and there at the bottom, kind of obscured. I'm going to put this online so you can see it properly. And there at the bottom, you see the inductive hypothesis. So that the red thing gives you the big structure, the kind of the skeleton of the proof, which if you get that right would be enough to pass the question. Now in black, you see some straightforward application of definitions, which is what people sometimes call just following your nose. Just working things inside, putting things in the definition, simplifying things, and making some progress. And there in orange, or yellow, you can see things that a place where I got stuck, and I'm using a lemma. So I want to show that the membership of X into reverse XS prime appended with the list X is true. And now, see there, I'm saying because membership of X in any list appended with X should be true, but which I don't have time to prove. So I'm using a lemma, which is true, but I don't have the time to prove. And that's fine. You can do that, because if you do that, you can always go back to it if you have the time and prove it afterwards. So that's the best thing to do. If you leave it like this, if it was just like that, you would get 75% of the marks. If you figure out the two lemmas that are missing, then you would get 100% of the marks. So again, I want you to pay some attention to this example because it really tells you how to give partial answers. It's very important to know how to give partial answers because it's a big difference between getting, maybe you don't know every question to do perfectly, but if you can get 50% of the points on every question, you will get 50% of the of the points of the overall exam. Final observations. The easy questions on the exam will be very similar or identical to non-starred assignments or examples that we did in class. If you know how to do those, you will get a good mark in the exam. So pay attention to everything that was a non-star assignment and everything that was an in-class example. And that will be enough easy question to not just to pass, but to get a good mark if you know how to do those. The hard questions will definitely not be as hard as the START assignment because you don't have time to do that. But they will be new, so there will be some questions that you haven't seen, not as a STAR assignment or not as a non-STAR assignment, and they will require an element of problem solving. So it's not the kind of thing where you just plug in the definition and it just works out. It will take a little bit of thinking to do it. And finally, if you need, you can always come and see me and make an appointment with me next term or before the exam if you need a little bit of additional help. So if I get more requests, I may organize like some one-off tutorial sessions. But especially for people who are struggling, not for people who want to get from 70 to 80 or from 90 to 100. People who are concerned about passing and say, well, I'm really concerned about passing this module and I need a little bit of help, and then we can go over the basics one more time. Okay, so let me stop here.